Hey everyone. Okay, so today we're going to start with our conversation on 7.4. And 7.4 and 7.5 are the only two remaining sections in this chapter. So here we go. 7.4 part 1 is all about rectangles, which, hopefully we've heard something about rectangles before in our, previous life experience and whatnot. But we're going to go over some of the more of the properties of rectangles and stuff like that you might not have heard before. Some of them you maybe have, some of them you maybe not. So here we go. Go ahead and flip to the notes in your brand new packet for 7.4 part 1. Okay, so starting here, first thing we want to note is that last week we talked about parallelograms. So a special note, a rectangle is a special parallelogram. Meaning that it has all the properties of a parallelogram plus some extras. So we're going to remind ourselves of some of the properties of parallelograms, and then we're going to add a few. So the first thing we want to say is that both pairs of opposite sides are congruent and parallel, but that's going to become a little bit less emphasized on rectangles. But if we want to draw a quick picture of that, we know that the opposite sides are the same length, just like that. Okay. We also know both pairs of opposite sides are, like I said before, parallel. Again, a little bit less emphasized with rectangles because the next thing is more important. All four angles measure 90 degrees. So all four, the sides are going to also be perpendicular to each other. So if we get a rectangle going like this, we should put right angles or 90 degrees in all the corners, just like that. Okay. So another property that we had for parallelograms was that the diagonals bisect each other. This is where we're going to add something else to it. The diagonals bisect each other and are congruent. So not only do we have something like this where we know that the diagonals cut each other in half, so that like this half is equal to this half, but also the diagonals are going to be the same length. So all four of these pieces are actually equal to each other in length. This is actually something that I've used before. So you think, when am I ever going to use this? When I was working on a little construction project at my house. I was building like a thing in my backyard, kind of a little shelter structure type thing. And it was in the shape of a rectangle. And so in order to make sure that the corners were 90 degrees, instead of getting something out to try and measure the corner, since that's not really the easiest thing to do when you're working with, lumber and stuff like that, we just measured the diagonals. And if the diagonals were the same length, then we knew that the corners had to be 90 degrees. We knew it had to be a rectangle then. So an instance where you might use math in real life, who knows? Anyways, on to some problems that you guys might see on your assignment and stuff like that. This kind right here, this is one of my favorites because it's kind of like a puzzle. You start with one angle and you can find all of the other angles in this picture just based off of that one angle. So that's kind of fun. And it has to do with some stuff that we've talked about previously. The first thing that we want to write is that all four of these are the same length. So we're using this property already. And when we do that, we might notice that now we have, if I just look at this part right here, we have a triangle that has two sides that are the same length. That's an isosceles triangle. And we know that on triangles, all three angles together add up to 180. And we know that on isosceles triangles, the base angles, which are these two, have to be equal to each other. So if I start with going 180 minus 68, and when I do that, I get 112. that means that together these angles must be 112 degrees. So I have to divide that equally amongst those two angles. So 112 divided by 2, which gives us 56, which means that both of these angles are 56 degrees. All right, well, let's keep going. We can also use the idea that this angle right here and this angle are vertical angles. So that means that if this is 68, this is also 68 because vertical angles are congruent. Then we know that if these are both 56, this is the same isosceles triangle that we had over here. So these will also be 56 degrees. All right. Now there's a couple of different ways that you can find your other corners. One of the ways is that you can notice that this angle right here adds to 180 with this one. So you could go 180 minus 68, which we've already done actually to get 112. And notice that this angle is also 112. And so then this vertical angle from it is 112 as well. Then there's a couple of different ways you could also get these corners right here. Because this whole corner is 90 degrees. So I could go 90 minus 56, which is 34. And that would give me this corner that's 34. And then this corner that's also 34. Because this is, again, another isosceles triangle. So these corners will be the same. And then this down here is the same isosceles triangle as up above. So these are both 34 as well. And now we finish the puzzle. So there's a lot of ways you can get all of those angles. That's one way that I like using. So it's kind of cool. You can find all of those angles just by using one. Well, let's look at some more properties of rectangles here. On this next one, it says MD. So this part right here is 2x plus 10. Then it says DB, which DB is this entire thing here. DB is 40 for that entire distance. Okay, so we want to find X. So again, something we want to remember from rectangles and also from parallelograms is that the diagonals bisect each other. So if this whole thing is 40, then half of 40 is 20. So these must both be 20, and these must also both be 20. Which means to solve for X, we can just go 2x plus 10 equals 20. And then we go minus 10 on both sides. We get 2x equals 10. Divide 2 on both sides. And we get x equals 5, which is all we were asked to do. All right. The next problem is going to remind us a little bit of parallelograms, or a lot bit of parallelograms. On this one, we are given AB, this distance here, which is 3x plus 6. And then DC, which is 5x minus 12. And on parallelograms, which also includes rectangles, we know that opposite sides are congruent. So that means that we're going to set these two things equal to one another. So we're going to go 3x plus 6 equals 5x minus 12. So we're going to go subtract 3x on both sides. We get 6 equals 2x minus 12. Add 12 to both sides. We get 18 over here equals 2x. And then divide 2 on both sides, and we get that x is 9. Okay. So those are, oops, sorry, there you go. those are 3 different kinds of problems that you might see involving rectangles. So now it's your turn to try one. Take a look at this. You've got AM is 12. So that's this part right here is 12. They tell you that AC, this whole thing here, is 5x plus 4. Solve for x. All right, so pause the video here, give it a go, then restart the video and see if you got it right. All right, hopefully you paused the video there. Here's how we would do this one. So again, knowing that this is a rectangle, we know that all 4 of these pieces are the same length. So if this one is 12, then these are also all 12, which means that this whole length here is 12 times 2, which is 24. So we can go 24 equals 5x plus 4. Then we can go minus 4 on both sides. We get 20 equals 5x. Divide 5 on both sides, and we get that x is 4. All right, so that's all of the notes. Go ahead and turn the page, and we'll talk homework. All right, so I know this homework page is a little bit cramped. Here's what we're going to do. This picture is for all of these problems here. And then this picture is for all of these problems here. Now, the nice thing about this picture is it tells you that angle 1 is 37 degrees. So when you go through all of these, this is just like example number 1. These ones, however, you're going to treat them each separately. So, for example, when it says that UZ is x plus 21, and it talks about this part, and then ZS is 3x minus 15, and it talks about that part, we know that those 2 pieces are equal, so we would set them equal. And so whatever I get when I find x and I plug it back in and all that good stuff and find the thing it asked me to find, when you go to the next problem, don't use the same stuff from here. We're going to kind of restart and like go back to it and like label each of these things separately on the picture. Okay, so on this first page here, your assignment is 1, 3, 5, and then all of these ones, 7 through 12. And then go ahead and turn to the next page. On the next page, we are going to do all of these ones. And I like this one a little better because there's a lot of room to kind of show your work and stuff like that. So that's why I'm doing more of these and a little bit less of the ones on the other page. For this one, you're using this rectangle for it. And it should be similar to the ones on the previous page and similar to the ones that we had in our notes as well. So don't forget to look back at your notes and stuff like that. Okay, I think that's enough of me talking now. Get to it. If you have questions or want help with anything, I'll be back in class tomorrow. So please hold your questions for then, or find a different math teacher or a friend who knows how to do it and ask them too. Use all your resources. All right, see you guys later.